So here we're going to talk about the shell method for calculating volume. So let's take a shape. So I'm going to draw an X and Y grid here. So we've got X, got Y here. And say I have a curve from A to B, okay? And I want to take that curve and rotate it about the y-axis. Well, as I spin, so say I take some arbitrary x value, right? And as I spin that around the x-axis like this, it creates this like, I don't even know, like have you seen those cakes where it's like the middle is like hollowed out kind of thing? That's kind of how this is. It's kind of hard. Oh man, how's that? How would I draw that? Okay, maybe I'm not having that much luck drawing this. Okay. Let me clear that out. Okay. So and then that's also see-through as well. Okay, so it's like the cake here is kind of hollowed out in the middle. That shape, that weird looking shape there. So something like that going on. Now, the problem here with the washer method, okay, the washer method, what it does is you have to have perpendicular rectangles, right? So that would be dy if we're rotating about the y-axis. But here's the situation. This drawing is like an upside down parabola, right? So that's y equals some negative x squared. I don't know. Maybe that's plus 4x minus 4 or something. I don't know. That may not work, whatever. But here's the thing. If I was going to do that method, I would need to know the right minus the left here. And so that means I would need to solve this to be x equals something, right? And so I would need a quadratic to solve this. And that just starts to get really nasty really quickly. Okay, so that's a pretty challenging problem. Now, the method of shells takes this problem that's really difficult and makes it a lot easier. With the shell method, instead of having a perpendicular rectangle, what we have is a parallel arbitrary rectangle, okay? And so as I rotate this thing around, it gets the thickness all the way around my y-axis, okay? And then you connect all your dots and it makes this shape here. Now, what is the geometric shape that's going on here? What is being created here? It's a thickness, dx thickness here. It's a hollowed out shell, okay? So it's just a little shell with thickness dx. All right, dot, dot, dot this. Okay, and so once again, it's hollowed out. Just like this. All right. Say now, and it's hollowed out on the bottom side too. You can't see the bottom side from the perspective that we have, but it's hollowed out. Say now what we do is we take a pair of scissors. Those beautiful scissors, right? And we snip, 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 snip all the way up one side. Okay, so I'm going to snip it on this one side here. All right, well then what happens? It folds out both ways and you end up getting a sheet just like this. Okay. Where that snipping that we did right down the middle here ends up splitting up just like that. Okay, and so it just folds out. You just fold it out. All right, and so what is it? Well, the thickness here is still dx. Okay, how do we get the actual length here? How long is this top side here, the bottom side too, right? How long is that? Well, it just so happens that that's the entire length, right? That's the entire length of what? The circumference of that top circle, right? So how do I find the circumference of a circle? That's 2 pi r. 2 pi times the radius. Okay? So when I'm talking about that scenario that I had going on here, that's an ugly little circle. I'm going to do a better job of drawing this rotation about the y-axis. Okay? So I've got my random rectangles that are rotating about. How do I find the radius of that circle? It's from the axis we revolve about to what? To that arbitrary x value. So that distance is x minus 0, which is just x. So that distance there, that 2 pi r, is really 2 pi x. Okay? And then, what else do I know? Well, I need to know what that height is. Okay, the height here. How do I find the height? Well, that's the distance from the x-axis of 0 up to that curve. And so whatever that curve is, if the curve is f of x, then that distance is f of x here. That height, h, okay, is equal to f of x, right? So to find the volume of this cylindrical shell, so this cylinder shell has a volume equal to what? Well, the volume is this rectangular sheet here, and to find the volume of a rectangular sheet is equal to length times height times width, right? And the length times height times width is 2 pi x times the height f of x times the width dx. Okay, so that's for one of those shells. And the idea here is we figure out what one shell is, and then we add in another shell, and add in another shell, and add in another shell, until we get all the shells that fill up the entire volume. And so we're summing all the shells from A to B. So the volume is equal to the integral from A to B of 2 pi x f of x dx. Okay, 2 pi x f of x dx. Now, this is for when you're rotating about the y-axis. Okay, so this is the picture for that problem there. All right, if you're going to go the other way, your volume is equal to the integral from C to D of 2 pi y times g of y dy, and that's rotating about the x-axis. Okay, so you're rotating about the x-axis. So if you think about this scenario, what this would look like if you're rotating about the x-axis, say you have some curve, some g of y. Okay, if you're going to let's just say this is the curve, right? So that's the enclosed area. So with the shell method, okay, with the washer and disc method, it's perpendicular. With the shell method, the rectangles are parallel. I like to say shell parallel, and then perpendicular. This is how I remember. So the shells are parallel to the revolving axis. So my rectangles, the arbitrary rectangles I draw, are parallel to the axis that I revolve about. So you see we're revolving about the x-axis here. I have a dy differential there, okay? And then you notice how there's a y here. Well, why is there a y there? Well, that distance from the x-axis to the arbitrary rectangle is a distance of y, okay? So that height there is that y, and that length there is that g of y function, okay? And so hopefully that helps you out. All right, and then when you sum from C to D, right? And so you start down low and you add up all the rectangles till you get to the top. And those rectangles are shells, okay? So when you rotate it about the x-axis, you get that shell going on. Okay. So hopefully that makes a little bit of sense. I'm going to do one example with this just so that you have something concrete to go off of for this video. And then we'll save another video for more examples of the shell method. Okay, so for this one, I have y equals x plus 1, x equals 0, x equals 2, y equals 0, and I'm going to rotate it. Oh, too many t's. Rotated about the y-axis. Okay, so first thing I do is I graph it. So if you got graphing paper, great. If you don't, that's okay too. Just mark everything so we know what you're talking about. Okay. So I'm rotating about the y-axis, so I'm spinning it about the y-axis like this. Now, x plus 1, whenever I do x plus 1, that's a slope of 1 passing through the intercept 1. So I'm going up like this. Okay. X equals 0 is the y-axis. Well, that's a good one to have. If it doesn't give you that, then just assume that's a bound because you're rotating about the y-axis. And x equals 2 is another one. X equal 2. And y equals 0 is the last one. Y equals 0 is the x-axis. So that's y equals 0 there. And so you can see that this is the boundary right there. So we're going to be taking this object and we're going to be spinning it around the y-axis. So what is this going to look like? It's going to look like in 3D. A cylinder with the cone taken out of the middle. Okay, so it's a cylinder with a cone removed from the middle there. Clearly. All right. Okay, so if we do this, remember to use the shell method. What do we need? Shell parallel. Okay, so parallel with the axis that we're rotating about. So we're rotating about the y-axis. So my rectangles are parallel. All right, so that means that I have a dx setup going on. So I'm dealing with the volume equal integral from a to b, 2 pi x f of x dx. So I need to figure out a, b, and f of x. So how do I do that? Well, a is the most left rectangle that we're summing. Whenever I look at this, I start summing from left and I go to the right. So I'm adding all the rectangles, all the infinitely many rectangles between those two. So what's that going to be? Well, this is at x equals 0 here. So this is going to go from 0 and then up to x equal 2 here. And there's 2 pi x f of x. Now, f of x is the height, okay? It's always the height. To do the height, f of x, I do top minus bottom, okay? So the top here is x plus 1 minus the bottom. Well, the bottom is just at y equals 0, so that's just subtract 0, so that's just x plus 1. So x plus 1 is my height function, dx. And so now I'm going to pull out the 2 pi, and I have 0 to 2. Now, x multiplied by x plus 1, distribute that, I get x squared plus x dx. And so I have 2 pi and then when I integrate, I get x cubed over 3 plus x squared over 2 from 0 to 2. And so what will this end up being? So whenever I do this, I'm going to have 2 pi, and then 8 cubed, I'm sorry, not 8 cubed, 8, 2 cubed is 8, plus 2 squared over 2, minus 2 pi, and then whenever I plug a 0 in, I get 0 there. So all that goes to 0. So I have 2 pi, and then I have 8 over 3 plus 4 over 2, which is 2. I can rewrite 2 as 6 over 3 to get a common denominator. And so that's going to get me 14 over 3 times 2 pi, which is 28 pi over 3. Okay? 28 pi over 3 there. All right, and approximately 29.322 is what you should be shooting for. So hopefully this gives you a good idea of how to do the shell method. It's unique, but it's a pretty good way of getting the volume whenever the disc or washer method just seems like it's going to be more headache than it is helpful. And so maybe we'll do one more example just to make sure we got the basics down, and then the next video we'll have a little bit more complicated ones. So example here, y squared equals 9 minus x, y equals 0, x equals 0, and then rotated. So I'm going to rotate about the x-axis. Okay, I want to use the shell method. All right, so they tell you to use the shell method and you don't use the shell method, well, you done messed up. All right, so use whatever method is instructed of you to use. Okay. If you first draw out this problem, well, it might be a little bit tricky to draw this equation. Okay. Remember, you have y squared. That's not a function of y. It's so we need to write, or it is a function of y, so we need to write x equals something. So let's do that. Let's take y squared equals 9 minus x. I'm going to move x to the other side and move y to the other side. So when I do that, I'm going to get x equals 9 minus y squared. Okay. And you know what I've told you in the past, the tilt your head trick. Tilt your head. Your head. Okay. What does that mean? That means if I swap x and y, so y equals 9 minus x squared, that's easier for me to graph. I know that I go up 9 units, and then it's a negative parabola, so it looks like this, right? So that would be y and x. But what did we do? We swapped x and y, didn't we? So we tilt your head, and so when you tilt your head, it turns sideways like this, doesn't it? Always tilt your head 90 degrees like this, okay? You're swapping that x and y, so the x becomes the y and the y becomes the x. All right, and so now what do I know? This graph is going to be looking like this right here. So this is the graph of x equal to y minus, or 9 minus y squared. okay? And we're going to rotate about the x-axis, so I'm spinning about the x-axis. I have y equal to 0, which is a horizontal line here, and then x equal to 0, which is a vertical line here. So I've actually cut off some of this. So let me do this real quick. Cut that off. All right, so my boundaries are right here at x equals 0, y equals 0. And so I'm taking this and I'm rotating this cross section about the y or about the x-axis, so it kind of looks like a bullet, a solid bullet. Which, by the way, if you're trying to buy bullets, good luck, right? Okay, so we got our bullet right there. We want to find the volume of that bad boy, and to do this, I want to use the shell method. So shell means parallel to the axis we're rotating about. So my rectangles are parallel. So I'm going to use blue to contrast this. So what type of thickness do I have? I have dy rectangles here. So now that I've drawn my rectangle, I know that I can do my formula 2 pi. So the formula says 2 pi y g of y dy, okay, from C to D. That's my volume. Now I got to figure out what is C, what is D, and what is g of y. Okay. So the lowest the rectangles go is y equal to 0. The highest the rectangles go is y equal to, well, I don't really know what that is, but I can figure it out. How? I set these two equations equal to each other to find that intersection there. So if I have x equals 0 and x equals 9 minus y squared, then 0 equals 9 minus y squared. And so y squared equals 9 gives me y equal plus or minus 3. So I got a 3 up here, and technically there's that other branch down here that gets you that -3, but we don't care about that one, right? So I'm summing from what? 0 all the way up to 3. So I'm adding all those rectangles from 0 to 3. That's what the integral does, adds all the rectangles. And then I do 2 pi y, and remember, for some arbitrary y value, that distance between the axis I'm rotating here and here is y minus 0. Okay, so that's where that 2 pi y minus 0 comes into play. Okay, and so that's why we just write y. And then g of y. Now what is g of y? That's the height. That's the distance that's right minus left. So the right is this curve. The left is this x equals 0 curve. So that's 9. So the g of y, the g of y is the 9 minus y squared minus the 0. So this curve minus that curve, right, to get this height of that rectangle. And so when you do that, you get 9 minus y squared dy. Okay, so I'm going to pull out the 2 pi, integral 0 to 3, and then I have y times 9 is 9y, and y times y squared is y cubed. Okay, And whenever I run through the math there, I get 2 pi, and then y squared over 2 times 9 minus y to the 4th over 4 from 0 to 3. So that's 2 pi times, looks like 81 over 2 minus 81 over 4, which is 81 over 4, I think. So 2 pi 81 over 4, which gets me 81 pi over 2. Okay. Approximation is 127,235. All right, so you do the math, check to make sure that that's correct. I'm pretty sure that it is. But that shows you how to do shell method with a dy version and shell method with a dx version. So hopefully this video was good for you to understand. When you're thinking about the formula, when you look at that formula, the x here, that distance is between the arbitrary rectangle and the axis that you're rotating about, okay? So it's only x if you're rotating about the y-axis. If you change your axis, like this was like y-axis, and then you had your x-axis, and say you had your shape here, right? But then you decide you're going to rotate about y equals -2. All of a sudden, that arbitrary distance between that random x and this axis here is not x, but it's right minus left. And so that's where that x minus -2 comes into play. And so then it would be x plus 2 would be what would go in here. Okay, so we're going to do another video where I show you how this works. I just want you to be aware of what we're heading towards, okay? So think of the x there as the distance between what? The distance between the rotation axis and the arbitrary x, the rectangle, the parallel shell. Okay? And then the f of x is the height of the shell. Okay? So however tall the shell is, okay, that height there, that's that f of x, height. All right.